This morning, I came across a question on Reddit that I think a lot of students are going to be asking themselves as this fall semester begins. What is calculus and why is calculus? What are the big ideas? So what is like the big thing about calculus? Everything I'm learning is pretty clearly like you have to learn this to get to the next thing, which helps you understand the next thing and so on. But I don't get what the final thing is. Like, pretend I'm going to be a calculus genius and learn everything there is to know. What is the final cool thing about calculus? Like, what's its big ideas? So in short, this might sound for a moment as anticlimactic, but I think the number one big idea about calculus is that it allows us to understand curves. And on one hand, that seems, like I said, fairly anticlimactic. It's like, imagine a whole field of study and it's like, yeah, we study triangles, which I guess is what happens to you in high school. But on the other hand, while that seems at the outset fairly bland, it's quite general because the world is curvy. The world is made out of curves. And so if we have a subject that allows us to study the properties of curves in general, that's actually pretty powerful. And when we start getting into the weeds of it, I think it does become inherently interesting because then we need to start grappling with concepts like infinity, things that are infinitely small and infinitely large. And all these things are essential ingredients into our formal understanding of curves in general. Let me try and tie this, though, to a bit of a practical, real world problem to maybe give some of those people who need the practical aspects a bit of an anchor. Let's consider this example that I think a lot of people come across in some form in high school. We've got a graph on the XY plane, except our y-axis is going to represent the velocity of some, car, or it could be a comet or something like that. And our x-axis is the time. And we suppose we have a graph like this, right? So it tells us how the velocity is changing over time. So maybe this is 5 seconds, and maybe this is 30 meters per second, for example. And we can tell some information about this object, right? So looking at the graph, we know that for each of these moments between 0 and 5 seconds, I can tell you exactly what the velocity is by just looking at that corresponding y value on the graph. But there's some other things that we can get out of this. For example, I can tell you what the acceleration is at any point in time for any interval of time between the 0 and 5 seconds. So if you know a little bit of physics, you might know that the acceleration is the change in velocity over the change in time. Well, the velocity went from 0 to 30 in a span of 5 seconds. So it's going to be 30 divided by 5, or 6. 6 meters per second squared. Got to remember your units. And there's one other thing I can read off from this graph. I can also tell the distance that was traveled in any interval of time. This is easiest to compute. For example, if I compute, so the distance traveled, again, will be the change in velocity multiplied by the change in time. So the change in velocity is, well, it's going to be 30 times 5 in this instance. So it'll be 150 meters traveled between 0 and 5 seconds. Okay, so what does this have to do with calculus and derivatives and curves and everything? Well, the point is that there's a calculus interpretation to both of these things, right? So the change in velocity over change in time, what is this really? Well, this is the change in the y value over the change in the x value. In other words, what this is the slope, right? The acceleration is just the slope of this linear line. What is the distance traveled? Well, it becomes a little bit more apparent if, say, I pick, I wanted to know the distance traveled between these 2 points in time. What I'm actually calculating when I carry that out is the area under the curve, or the area under the straight line between those 2 points. Now, these are very easy calculations to make precisely because this line is straight. We know that the slope is the same anywhere, so we can calculate that between any 2 points. And similarly, the area is just this trapezoidal shape, right? I can sort of break it up into thinking about it as this square and this triangle, and there's some very basic rules of geometry to describe those shapes. But now I ask, what if I had a more complicated velocity versus time graph? Suppose that I had some weird curve like this. Well, what's the acceleration? What does that even mean? Because the acceleration itself is changing. So the acceleration itself, it's not even just a number. It itself is some sort of function. What that function is the derivative of the function describing this graph. And how do I figure out the distance traveled? Well, in the same way, it's the area under this graph. But how do I figure out the area under some complicated curve? Calculus. So in short, calculus tells us about curves. This can be applied in all sorts of physical situations. The rates of change of stock markets, of a car moving, of the YouTube algorithm, machine learning, AI software, all of this incorporates these ideas of rates of change that are not linear, meaning not in a line. And in my opinion, that's the essential core idea of calculus.